Today, we're going to present about the analysis of DNA stored-based DBMS and suggestion for its development. As you all know, as the modern society, which is also known as the age of the new information, progresses, the huge amount of information is being generated even at this moment. Then, what will happen in the future from now on? According to Data Age 2025, the world's total data scale will grow 10 times more than it is today to 163 zettabytes. This is why people think that we should have a new type of DNA storage medium in order to handle this amount of data. And to that end, people have evolved a lot of data storage in order to storage these data. And today's topic, the DNA storage, is a concept that have evolved from these backgrounds. So our study's topic is two things. The first thing is to find out what exact DNA management system should be in place before the commercialization of the DNA storage. And second, to suggest the features of it which fits the DNA storage. So let's take a moment to see what exactly a DNA storage is. In short, a DNA storage is a line of a data which is stored in the DNA. If I tell you just like this, you may be wondered how this exactly works. The encoding system varies from lab to lab, but the basic fragment is just as follows as like this. The data goes in, and the data synthesizer, PCR thermocycler, and the DNA storage library, and the DNA sequencer. To explain the process more specifically, it goes on the three procedures, just like that. The first is the encoding process. In the encoding process, the binary codes just as 11 and 10 and 01 and 00 are turned into the nucleotides, just as A, G, C, and T. And the next process is the retrieval and the synthesis and the sequencing and the storage. And the final chapter is the decoding process. In the decoding process, we turn back the decoded codes back into the ordinary codes, which are just as 00 and 01 and 10 and 11.
Then let's take a step of DNA storage made over the last 10 years. The first of research is in 2007. The research then made device that using addressing molecules to encode mismatched styles with DNA strands. The next research is 2012, which is used the encoded DNA with digital information that includes one HTML draw workbook and 11 image files, and also one JavaScript files. These features tell us that the DNA storage can be another type of data management system, just like hard disk or the magnificent types. The third one research is the 2013. The new technology in 2013 is innovation of error correcting including schema to ensure the extremely low data loss rate. The last one is the 2018. The newest research is the new technologies of random accessing data in the DNA. Try to find the conclusion. We should analyze the pros and cons of DNA storage and to find the advantages and disadvantages of DNA storage. And we should do one more that. Try to suitable DBMS of DNA storage based on their history. In this In this screen, we can find that DNA storage is unstructured data and also big data. Our DBMS, which is first appeared database type, is normalized data into table from column and rows. So it has access attributes and gives in data integrity. However, the increasing unstructured data, the fixed format of database like our DBMS is invalid. So NoSQL, or just say NoSQL, is appeared that is more flexible. NoSQL has the easily scalable and easy to control to big data. So we suggest that DNA storage is suited for the NoSQL, not our DBMS. And also we treat DNA storage as like a OLTP database dealing with big data. Our research that we conducted is pretty significant because we made the background of DNA storage commercialization. And also we give a pass for junior who has studying with similar topic like us. However, our study is based on just only documents, so we didn't process experiment of our recommendation. So we tried to find the more detailed conclusion and more deep research. Thank you for listening.
완벽하게.
일단
소리 깜깜.